Hello, welcome back. Today's video will be discussing single displacement reactions, and it's a very simple reaction. A very general writing, this single displacement reactions would have a compound reacting with usually an element to have it like so. Oh, there you go, brain farted. And notice how this now is becomes to a compound while the other element is now rejected. And this reaction fairly occurs quite not too common, but occurs commonly, but not that obvious in everyday life. But it does occur. And a good example of this would be we have a ferric oxide F2O3. Let's put it in solid states with its sodium. And it would have to react with plus 2Fe. Solid. This guy's also a solid too. There you go, making sure. And this is a reaction of single displacement. As you can see, my reactants reacts with the compound and it removes the iron like so. Okay, so we're going to go in depth and I'll discuss the different kind of reactions. Okay, a first reaction that's very simple and we'll see very often. There's a metal displacing another metal. Another metal. Similarly, we're going to have also a metal displacing the hydrogen in acids. Let's write it correctly, sorry. Acids and water. And finally, a nonmetal displacing another nonmetal. Okay. So we're going to go through each one of them, and then I'll quickly explain what happens and how it occurs. So for the first reaction, metal displacing another metal. There you go. Sorry. And a good example of this is when you have a copper wire inside a silver nitrate solution. It's a pretty cool experiment. I hope someone would. Oops, wrong number. Would demonstrate this to you in class. It's a really neat thing to see. Okay, enough room. And silver. Okay, this is an aqueous solution. Same thing with this guy here. And solid state. Okay, and this occurs in the solution. You have my copper wire floating, and I have in the solution silver nitrate. As time goes by, eventually the copper would shift, displacing the silver displacing out of the compound. So you create another solution, another aqueous solution with while you form silver. Sorry, yeah, while you form silver. However, something interesting that we need to mention. If I do the reverse reaction of it, well, I don't need to write that. You know your states, right? I don't need to rewrite the states. To create copper plus, okay, something like this. This does not occur, and there's a reason why. I'll use another color so you can see properly. This does not happen, and the reason why it doesn't happen because one metal is more reactive than the other metal. Copper is actually more reactive than silver in a solution. Okay, you can't notice unless I tell you. There in references in literature and textbooks, we have to look for what we call an activity series. Oops. Inside the table of activity series, it will tell you which metal would react more likely to react than the other one. And this is something that we need to have to predict, necessary to predict. Let me write this down for you. Necessary to predict. And I expect you to able to predict the reaction. I expect you that if I give you this equation and these reactants, that you will give me these products. Or if I give you these reactants, that you could tell me for sure, with certainty, that this kind of occur because of the activity series table. Okay, so we'll go to the next reaction. In this reaction, we have a metal displacing hydrogen from acids or water. Yeah. And a very popular experiment that I personally like is the magnesium with hydrochloric acid. Okay, don't forget, HCl by itself is actual liquid form. If you want to do the acid, we need to mention it as AQ. This guy's my solid, and this guy reacts to MgCl. Oh, I need to. There you go. That makes sense. Plus H2 gas. Enough room. All right. Don't notice that I have my my magnesium displacing the hydrogen out to become a gas state. And now, not all metals react with acids. You would need to refer to your activity series to determine if they do react. If you look at your table, you will see there will be a threshold line saying that at this point on, these metals can react with acids, while these guys under it will not. And I'll go over it in class, and don't worry about it. But you have to understand that not all metals react with acids and water. Another situation that you have when you have metals reacting. It's my sodium reacting with my water. Again, this is gas. This guy's my aqueous solution. Again, that's my liquid state, obviously. Okay, now we need to balance it. So I need to this, to this, to this. Alright. Again, notice that this guy is displacing my hydrogen. Right here, hydrogen out of it. But what's interesting about when you react with your a lot of colors going on here, it's gonna be very trippy. When you're displacing water, okay, you're always gonna have a metal hydroxide involved. Okay, you will create hydrogen, yes, but one of the products will create a metal hydroxide. In contrast, while my displacement with metal and a acid, I will not have a hydroxide. It was just basically another ionic compound. Alright, so we're going to do one last reaction. It's a non-metal. Just saying another non-metal. I'm going to give you another very popular uh, popular reaction is a chloric gas reacting with my sodium bromide. Excuse me, creating sodium chloride and bromine. Bromine is liquid state. This guy is under aqueous solution, and HCl is aqueous solution as well. Oops, yeah, sorry. Okay. One thing that you need to notice that the non-metal, the ones we're looking at, are usually halogens. Not any halogen, diatomic halogens. Oops. Okay. So like chlorine with 2 of them, fluorine with 2 of them, bromine. Oops, this guy should be my mistake. This guy should be 2. Bromine, and so on. So these are my diatomic. We are looking only for diatomic halogens. There are other nonmetals that could possibly displace another, but the reason why we picked this one, because in this particular situation we do also have a just not here, a non-metal. Wait, not non-metal. Sorry, I'll write something else. I'll write activities series. For halogens. It's very similar. Halogens. It's a very similar table as the activity series for metals. So the reason why we picked this for halogens, because we could also predict the possible ones thanks to the activity series that's given in literature or in textbooks or in references and so on. So again, if I give you a reaction with a diatomic halogen and a compound, you should be able to tell me what will be the product, or if it's going to be reacting or not. Okay, this is a very similar situation if I did a metal displacing another metal reaction. I guess that's it for this video, and I'll see you next time.